Four forces are acting on 28 by 15 centimeter plate as shown in figure. Find the resultant of these forces. Locate the 2 points where the line of action of the resultant intersects the edge of the plate. Now first, let us find out this theta 1. Theta 1 is given by tan inverse of opposite this side, that is equal to 15 by adjacent, that is equal to 8. So tan inverse of 15 by 8, and this theta 2 is given by opposite by adjacent 15 by 20, that is equal to 36.87 degrees. Now first let us write the angles. Theta 1 we got 61.92 degrees, and this will be equal to same angle 61.92. Now resolving this one into horizontal and vertical components, and now writing theta 2 we got 36.87, and this angle will be also equal to this angle 36.87. And now resolving this 125 into horizontal and vertical components. Okay, now resolving forces horizontally and vertically, summation fx and summation fy. Summation fx, so for 85 Newton, horizontal resolution will be 85 cos 61.92 degrees. It is directing towards positive x-axis. So 85 cos 61.92 degrees directed to positive x-axis. Now resolving this 85 Newton into vertically, it is 85 sin 61.92 degrees directed to positive y-axis. So 85 sin 61.92 degrees directed to positive y-axis. Now resolving this 125 into horizontally, it will be 125 cos 36.87 degrees. It is directed towards negative x-axis. So 125 cos 36.87 degrees directed towards negative x-axis. So minus. Now resolving this 125 into vertical component, it will be 125 sin 36.87 degrees. It is directed towards positive y-axis. So 125 sin 36.87 degrees directed towards positive y-axis, so plus. Now resolution of this 100 Newton will be 100 Newton vertically, it will be directed towards positive y-axis, so plus 100. Now resolution of this 240 Newton will be 240 only, it is directed towards negative x-axis, so it will be horizontal resolution, and it will be 240 minus directed towards negative x-axis. Now calculating all this, we get summation fx value. Now calculating all this, we get summation fy value. The resultant is given by the equation r equal to square root of summation fx square plus summation fy square. So r, substituting summation fx value, summation fy value, we get r as 390.512 newtons. Now resultant direction is given by theta equal to tan inverse of summation fy by summation fx. So theta equal to tan inverse of summation fy divided by summation fx. So theta we get as 39.8 degrees. So based on summation fx value, summation fy value, we can know which quadrant the resultant is in. So summation fx value we have is minus, so minus summation fx value directed towards negative x-axis, and summation fy value we have plus, so it is directed towards positive y-axis. So the resultant is in the second quadrant. We know the resultant lies in second quadrant, but to locate exact position with respect to uh, one of the edges, we have to take moment of all force components about some of one of the point reference point. So taking moment of force components about point A. Now taking moment of this component about point A, this force component will pass through line of action of force about point A, and it will have zero perpendicular distance about point A. So its moment will be zero about point A. Now consider this force, and it will be the line of action of force, and this force will pass through point A like this, and it will have zero perpendicular distance about point A. So moment of this 100 Newton force about point A will be equal to 0 because it will have zero perpendicular distance about point A. Now consider this force, and this will be line of action of this force. It will pass through point A like this, so it will have zero perpendicular distance about point A, so its moment about point A will be equal to 0. Now consider this force, and it will be line of action of this force, so this force will pass through point A like this, and it will have zero perpendicular distance about point A, and its moment about point A will be equal to 0. Now consider leftover forces, force components. This is one force component and this is another force component. So now see, this force component will pass through point B like this, and it will be line of action of force of line of action of this force component. So it is passing through point B, and it will have a perpendicular distance of this much, that is 28 centimeters from point A, and this force will pass through point C like this along the line of action of force. So this will have a perpendicular distance of this much, that is 15 centimeters from point A, and this force will rotate about point A like this anticlockwise, and this force will rotate about point A like this clockwise. So moment about point A is given by this force into this distance and this force into this distance. For this force it will be anti-clockwise, and for this force it will be clockwise. So minus for this force and plus for this force. This force, this force, this force and this force, they all are passing through point A. For them, moment about point A will be equal to 0. Only force components which are having moment about point A are this force component and this one force. Now calculating all this, we get moment about point A and D, that is perpendicular distance of resultant force from the point A, will be given by summation MA by resultant. Substituting values, we get D value, and x-intercept is given by summation MA by summation Fy, that will be, and y-intercept is given by summation MA by summation Fx. So substituting summation MA by summation Fy value, and summation fx value, we get x-intercept and y-intercept. Now, locating resultant, we have some x-intercept 6.05 centimeters from A and y-intercept 5.04 centimeters from point A, and D, it will be 3.87 centimeters from point A, and resultant is having 390.512 newtons, making angle of 39.8 degrees to the horizontal. So this is how the resultant is located about point A.